Hello, future engineers. To inspire me in my work and to keep me going and refresh, energize, please don't forget to share my videos to your friends, to those who haven't yet subscribed, because this is a very tiring work and many of you can benefit my work definitely. But to keep me going, inspired, please share my videos. That's the only way you can help me promote my channel. So this is problem example 102G by conjugate beam method, my favorite method aside from double integration and Castigliano's second theorem. So modulus of elasticity 200 gigapascals, moment of inertia I is 500 times 10 to the 6, and the moment of inertia for portion ABC 2I, for CDE just I. So in this problem, I select C as the moment center. So let's solve for the reactions first. Summation moment D0. So By times 10 equals By times 10 plus 15 times 1, then minus 40 times 6 minus 20 times 12 equals 0. So By is equal to 46.5 kilonewtons. Likewise, summation moment B or MB equals 0, counterclockwise positive, RD times 10 plus 20 times 2, then minus 40 times 4, minus 15 times 11, so R sub D is equal to 28.5 kilonewtons. So let's now have the conjugate beam. So the free end becomes fixed. This interior pin becomes interior hinge. Then this roller becomes interior hinge. The free end at D becomes fixed. So that's it. For moment, so 20 times 2 is 40, but the moment of inertia is 2. Divide by 2, so it is just 20 here. 20 times 6, 120, divide by 2, so 60 over EI. So here, this is 20 over EI. Then due to 15, due to the reaction, 46.5 times 4 divided by 2, so 93 over EI. And due to 15 times 7 over 1, so 105 over EI. And 15 times 1, 15 over EI here. Due to the reaction, 28.5 times 6 is 171 over EI. So since BD is the simply supported portion, so let's solve for theta B first. At B, there's only theta B or shear, but no deflection. So let's divide this trapezoid into these two triangles, and this trapezoid here into that triangle. So the forces or the areas, so that's a positive theta B, because this is the left section, this is the right section, this is the positive theta D. So this is the area of the triangle, upward area of this big triangle, area of small triangle, bigger triangle, small triangle, and bigger triangle. So summation forces Y for the portion BD, 0. So theta B, MD equals 0. So, sorry, summation moment D equals 0. To solve for theta B, there are two unknowns, so we can solve theta B unless the equation is equilibrium equation, summation moment D equals 0. So theta B times 10 equals theta B times 10 plus this area, which is 0.5 of 4 times 93 over EI. The moment arm is 4/3 plus 6. So 4/3 plus 6. plus this area, moment of this area, 0.5 of 6 times 171 over EI. The moment arm is 2/3 of 6 of 4. Then minus the moment of this area, minus 0.5 of 4 times 20 over EI times quantity 8/3 plus 6, where 8/3 is 2/3 of 4, so 8/3 plus 6. Then minus the moment of this area, 0.5 of 4 times 60 over EI. The moment arm is 1/3 of 4, or 4/3 plus 6. Then minus this small area, minus 0.5, moment of this area is 0.5 times 6 times 15 over EI times 2, 1/3 of 6 is 2. And lastly, moment of this area, about D, minus 0.5 times 6 times 105 over EI times 4, where 4 is 2/3 of 6. So we can now solve theta B. Theta B is equal to negative 1259 over 15 EI, but that's not required. Next, let's consider BC. So let's remove these forces that are not important. So this is the positive theta C, then positive delta C counterclockwise. So considering BC, summation forces Y equals 0. So theta B, which is negative 1259 over 15 EI, plus this area here, plus 0.5 of 4 times 93 over EI, then minus this area, minus 0.5 of 4 times 20 over EI, then minus this area, minus 0.5 of 4 times 60 over EI, then minus theta C equals 0. So we can now solve theta C. Theta C is equal to negative 869 over 15 EI, and EI is 200 gigapascals times 500 times 10 to the 6. By experience, that's 100,000 kilonewton meter square. So therefore, theta C is negative 869 over 15 times 100,000. So theta C is in radians, negative 5.793 times 10 to the negative 3 radians. Or you just leave that way, that's interpreted in radians. Then for delta C, summation moment C equals 0. So we just add the moment arms, we just multiply the moment arms of these terms. So negative 1259 over 15 times 4 plus 0.5 of 4 times 93 over EI, this is 4/3, then minus 0.5 times 4 times 20 over EI, 8/3, 2/3 of 4, 8/3, and minus 0.5 of 4 times 60 over EI times 1/3 of 4, 4/3. Then minus delta C equals 0. So solving for delta C or deflection at C is negative 354.4 over EI. So the shortcut to convert that to mm is we just divide by 100. So delta C is negative 354.4 divided by 100. So delta C is negative 3.544 mm. So that's it for this problem.